Hi guys, okay, let's continue with dynamic structure allocation. Now, dynamic allocation of memory is especially useful for list of structures, right? Um, it basically permits lists to expand and contract as a record are added or deleted. You know, so this is kind of important when we're creating something like a file structure, a list of participants, right? We don't want to use more memory than we want to, right? Or allocate too much memory when we don't really use that memory, right? So having this dynamic structure is really useful, right, in our program, right? So so whenever we require additional storage space, we use new operator and indicate the amount of storage that is needed, right? So the expression that we used earlier is new some integer or new int that requires enough space to store a integer number, for example, right? So as we go on, right, now we've seen these two before, the new and delete operator, right, making us capable of creating a new uh, uh, and reserve some memory for the particular allocation, the memory allocation that we want, right? So in struct we can use the same thing, dynamically requesting storage for a structure. So we would have a struct teletype, for example, which has the name and phone number. So this is a data type that it contains two members, both are strings, right? So teletype, we can express new teletype, right, which will reserve storage for one teletype structure, right? So in 16.7 we can see an illustration of this program, and we can look into this program in such a way that we have a struct here, right, and we have two functions. One is to populate this struct, and one is to um, this dispose or display one teletype, I think, right? So let's look at this program here, right? So in the main function we have we create a pointer teletype, right? And once we have the pointer, we can get the record. So do you want to create a new record? And we say yes. If the answer is yes, then we dynamically create a new struct for it, right? So key equals to cin.get, we get the value that it wants to enter, right? And we create and we point it to populate rect point, right? So in the populate structure, we can see in the populate function, we can see that we can ask for the name and we can ask for the phone number, and here we can put record, use the uh, arrow sign here to name, to give the value into name and phone book, right? So once this is entered, then that's fine, right? And if we look back at the program, after we populate, we display one. So here we would just display the contents name, right, and return, right? So it's a simple function, and as we continue saying yes, if the key is definitely Y, it will keep on repeating and asking for us to enter data, right? So as we enter yes and enter new data, it will create a new struct for every each loop, right? Which is a nice thing to have, right? That way we only use memory when we need to, right? So 16.7, we can refer to the textbook if you have the textbook with you, right? Basically, like we said earlier, there's two functions, two members, one pointers. Teletype is the struct that we use, the structure, and we keep on creating a new structure using assign it as a new pointer, right, every time the loop goes through, right? Okay, so we can read the explanation there. Now we go ahead to unions, right? Unions are data type that reserve the same area in memory for two or more variables that can be different data types, right? So this is a bit different, right? So by definition, a union has the same form as a structure definition. So except for the name, but instead of a struct, we use union. Then we have three members here: key, integer, or double price, and some indicator variable, the union name, right? So, and as we look at this, a union reserves enough memory locations to accommodate its largest member data type, right? So it will just create it will basically create enough memory locations for the data type that we are referencing to, right? uh, we can access union members as the way we use struct. A data type can be associated with a union. A union can be members of a struct of arrays, a structure, a pointer, and such on, right? So okay, let's look at an example here where we are using union, right? So previously we have struct, and we learned about struct. Now we are adding a type called union here. So we define the union here: union student 1, right? So this is a global declaration, and so we can say student 1, which is a union, right? Student 1, student 2, which is just a normal struct, right? So remember, accessing it is so here our program would display out the size of the union and the size of the structure, right? So here in a structure we have 32 bytes, 4 bytes plus 4 bytes, right? So 32 plus 4 bytes plus 4 bytes, right? Here ideally we have 32 bytes, right? So it will allocate the largest largest member memory space, right? Okay, now let's look at the use of the union here. So we have a example 2 here. We have a union of gender, metric, and CGPA as the members, and now we can assign student grade equals to F, right? Student gender equals to F, female. Metric number 1, 2, 3, 4, 5. This is integer, and the GPA is 3.1, right? Now in this structure, the largest data type would be double, right? And it will basically define enough just to hold the double value, right? So if we want to print out gender, metric, or CGPA, right, and the output would somehow come out as correct up to 3.1, right? The others would be -858993459, which doesn't make any sense, right? Now in union example 3, we have character C double and double B type here. Still the largest is the double B type here, right? So and if we define here as Y and 20.5, C out would give the correct value there, right? It should come out as 20.5. Okay, let's see. So the program displays nothing because the memory space for CH has been occupied by B type and thus overwritten, right? Now the value of B type is occupying the same memory space. So if we see out alternate dot ch, we won't get any output basically because it's occupied by B type, right? Okay, so a union as a member. So can we have a union nested into a struct, right? And see how does that look like. So we have a struct with a character, we have a union here, right? With either text, float, rate, and we call it utext, name of the union, and flag, right? So we can access the variable rate, right, by using flag utext right there, and then rate right inside of the union, right? So in this part, rate would be the biggest data type, right? So union is particularly, we don't really use it often unless for some cases, right? And here we can see that it does have some peculiarities on how we would use it, right? Since it allocates for the largest data type, right? Okay, so let's try to look at the common programming errors. If we're trying to use a structure as a complete entity in a relational expression, right? Bear in mind that only individual members of the structure can be compared, but not the entire structure, right? So if you're trying to relate one struct with another, bear in mind that we can only compare the members, right? So if we want to somehow arrange them in a certain order, then we need to basically write the logic for it, right? Which member do we compare first or compare second, etc., right? Now, using pointers in relation to structure and not indicating proper data type, right? So if we're using pointers in relation to a structure and we don't indicate the proper data type, this can be a problem, right? Now, when using union, because union can store only one of its member at a time, you must be careful to keep track of the currently stored variable, right? So this is you got to be careful with that, right? So because it keeps data only one member at one given time. So if you're trying to access them separately, you might have a problem, right? Now a structure allows individual variables to be grouped under common variable name, right? A data type can be created from structure by using declaration form. So you can have struct data type, then individual member declaration, and make sure you have those, right? And make sure how struct works. Now structures are useful as element of arrays. In some cases it's more useful than arrays. It has a complete structure that can be functions of arguments, so you can write it almost and access it almost like a function. Structure members can be any C++ data type, including structures, unions, arrays, and pointers, right? Unions are declared at the same manner as structures, right? So make sure you have these pointers and remember about them when you and understand the concept for structures, particularly using pointers in structures and union, that is, right? Okay, so we're done with chapter 9. I hope to see you later in chapter 10. So have a good day, everyone, and we'll see you again soon. Bye.